Jergelind. I'm working in Sweden, in the Stockholm area, as marketing manager for small and mid-sized wastewater pumps. I hope you have all had a good lunch and that you have loads of energy right now. This is really the best session to have for a day like this with loads of information, but I'm sure I will keep you awake. First of all, I must say that the introduction here today, made by John Tonkin, was really a pleasure for me to hear. It was music in my ears, because I'm actually having the same message with me here today, and I can assure you we haven't done any free talk before. So what we are going to do this hour is, first I will talk a little bit about Flygt, and then we're going to have a big launch of Flygt Experior here in Africa. And I'm really, really excited. And I'm also glad that now I have the time to talk about wastewater pumping. Here on the screen you can see our Flygt brand values. They are not really true customer values, but that is something that you can expect from a customer as a global supplier we are within wastewater pumping. First, when it comes to reliability, it's very product-oriented. It's about trouble-free pumping. Our ambition and vision is that you will be able to install the pump and then you more or less can forget about it. It's also about our ability to deliver as promised. Second, it's about engineering excellence. For me, engineering excellence has two perspectives. The first one is to continuously introduce new innovation optimized for wastewater pumping. Actually, we first introduced and also developed the first submersible motor for wastewater pumping in the world. It was in 1957. That means that we have more than 50, 60 years of experience of wastewater. And if I look today at our capabilities within product development, working with only wastewater, we have about 630 years of experience within hydraulic design, motor, and seals. And that's quite amazing. This experience we have also utilized when it comes to system engineering, to our application knowledge. Yesterday we talked a lot about wastewater. It is an unpredictable media, and therefore system engineering is essential. Knowing what product to select, so it meets your requirement of your system, and how to install, operate, and maintain the product, so you over time will have reduced cost of ownership. The third part about closeness to customer. Of course, that is the most important thing in our day-to-day business, to work closely with you, to help you to overcome daily challenges and troubleshooting. This within our sales, but also within our service organization. As said earlier, I'm delighted because now it's about wastewater pumping, but just a very short glimpse what we can offer when it comes to Flygt products, Flygt pumps. There is a number of applications where we daily give support and do new installations. We have classical sewage pumping within municipalities, but also treatment pumping, as we discussed yesterday, and sludge pumping. But nevertheless, we have also clean water installations, like stormwater, which is a big business for us. We also can manage agriculture and aquaculture, and last but not least, we have installations in aquaculture, specifically in the US market. To be able to meet all those applications, we have a huge product portfolio. I won't cover that today, but I just wanted to give you a glimpse of what we have. We have centrifugal pumps from 1 liter up to 3,200 liters per second. So it's a really broad product portfolio. We also have grinder pumps that are typically to be used in a PSS system, pressurized sewage system. It's a smaller system for households. We have shopper pumps for more demanding applications. Also vortex for a more simple wastewater, and stainless steel that are suitable for typical industries. And also propeller pumps. Yesterday we had the opportunity to introduce a totally new range of propeller pumps here in South Africa. It's called Slimline, and it's a very nice product for application with a low head and high flow, like inlet station or stormwater applications. Nevertheless, we have the pumps, but we also have the pump station knowledge, as I talked about. And we have prefabricated pump stations in different sizes. We call them micro, config, and top. And of course, we can engineer solutions suitable to your needs. Something that we are very focused on is the packaging, to combine the right product with the right pump station, together with the monitoring control equipment. I have a really broad list here with a variety of what we can offer. Everything from supervision and SCADA system to controls, drives, control panels, and level and pump sensors. So hopefully I just have given you a high level of our capability, because now I'm going to focus more about wastewater pumps up to 70 kilowatt. So by that, we're now going to have a launch of Flygt Experior. With me here today, I have a very bold statement saying that you will be able to save up to 50% energy. And you will also increase your reliability thanks to Flygt Experior. And I will now explain what is Flygt Experior about and how are we able to have such a bold statement. Before I move on, I just want to give you a short glimpse of the history, and then we go back further into the future. So please click on this film. Now, pay attention. Flygt Experior is actually built on the premise to deliver reliability, efficiency, and simplicity. Those are actually true customer values. Over the years, we have conducted several marketing studies. We have been traveling, meeting customers, and always, of course, reliability is the most important part when it comes to sewage pumping. When that is fulfilled, you are looking for efficient pumping. A new trend that we see is that simplicity is becoming more and more important. It should be easy to install, but also easy to maintain. So, with reliability, efficiency, and simplicity is actually what this session is all about. So, what is Flygt Experior then? Flygt Experior is the best technology that we within Flygt and Xylem can offer when it comes to intelligent pumping, motors, and hydraulics. So what we are doing now is that we are introducing a new smart intelligent control, and we call it SmartRun. This is really a unique product. You can't find it anywhere else in this business. Also for the full range, premium efficiency motors are available. And the best that we can offer within hydraulic is of course our end technology. But now we are expanding our range with a new technology, and we call it adaptive N, up to 7.4 kilowatt. What I will do now is I will go through one by one, talking shortly about the technology and how you will be able to save energy and improve your reliability. I will start up with the hydraulics. Flygt N technology, hopefully every one of you have heard about it before. It was first introduced in 1997, and since then we have over 300,000 of installations all around the world, and that's quite amazing. So we have testimonials from several customers that really can confirm that we are saving money thanks to the self-cleaning design of the impeller. The self-cleaning design will provide sustained high efficiency, and it also improves the reliability, and you will get trouble-free pumping. We have also different choices of material of the impeller, so we can meet any challenging application out there. Last but not least, this specific design of the impeller also works very well when running at a lower speed. It is a proven technology, many of you have heard about it, but still I will go through the technology before I introduce adaptive N. So Flygt N technology is basically about 3 different functions that are working seamlessly together. First one is the back swept leading edges. You find them here. And this is the area that first hits the water. So please remember that. And then we have the guide pin. And last but not least, here painted in red, you can see the relief group. I have an animation with me, so I will be able to further illustrate how it's working. But before I do that, I will try to explain. So what's happening in the pump housing is that the brief will enter the inlet, and the back swept leading edges, together with the guide pin, will push the solids out to the outer edge of the pump house. Then it will pass along the relief groove out through the volume and pump. So the self-cleaning is actually about letting the solids slide along the leading edges out through the pump. This animation, here is from the side and here is from underneath. I will turn it on and explain again, but please first have a look at the smaller image here. So now you see the solid passing through the pump smoothly, and we take it in slow motion. And while the solids is passing, you will see how the leading edges together with the guide pin pushing the solids out, and then it's sliding along the relief rope. And this self-cleaning design will reduce the consumption of energy. We often say that we deliver sustained high efficiency. I hope you know it by heart, but anyhow, I will explain it also. How can we achieve energy savings? When we look at typical conventional pumps, we have run tests in our laboratory, we can see that the breeze is building up over time. And with sustained high efficiency, the definition of that is actually that the pump can keep its initial level of energy over time. That's the definition. Meanwhile, the conventional wastewater pump, what will happen is that the energy consumption will increase. It's using more power. And the reason for that is something that we call soft clogging. The breeze is building up on the leading edges. It seems like the pump is running efficient, but in the truth, it uses more power. Of course, you can run a pump intermittently, then you start the pump, and then over time the grease will be built up and it uses more power, and then it stops, and it will be, the solid will be flushed away, and then the pump starts again, going up to the same energy level, etc. But over time this will also increase the energy level. But with an end pump, you will have sustained efficiency over time. And that's why we say that you can save up to 25% energy with an end technology. Now we have a crystal clear picture of what an end pump and the end technology is all about. And then I'm gladly going to introduce the adaptive end. The adaptive end technology is based on the same principle as the end technology. We are introducing it on the 3 smaller sizes in this range, up to 7.4 kilowatt. And what it will deliver to you is improved reliability. I will explain soon how. And it will still deliver sustained high efficiency. So the technology is actually about the smaller sizes of pumps. It will run smoothly as it always has done, but if a larger debris enter the pump, it won't stop. What will happen is that the impeller will move actually upwards, and then the hydraulic pressure will take the impeller down to its original position. And this happens in just a split second. Positive also, except from the reliability, is that the pump's lifetime will increase, since it will reduces the stress on the seal and the bearings. So that's also a benefit that you will get. I can talk a lot about animations here today and illustrations, but I think it's more exciting to see something from a real installation. So before I went here to talk about adaptive end, we did a film from our laboratory. And as you know, wastewater is unpredictable, but it's also hard to film. So what we have done now is that we have trying to illustrate wastewater by using plastic bags, plastic bottles. We also have socks, t-shirts, dishcloth, and some underwear. Typical things that you can find in wastewater. What we also have is a very small pump in this film. It's the 3085 adaptive end. Pump in this size, 2.4 kilowatt, and the inlet is only 10 centimeter. So this is a challenging testing that we are doing, but we must challenge ourselves sometimes. So if we please push the button and we can run this film. So there is the plastic bag, bottle, that's the t-shirt, this is actually my favorite, the dishcloth, so have a close look soon. It says. So now with your increased or up-fresh level of knowledge when it comes to end technology, you can see how the solid was pushed through to the outer edge. So by that, I also want to mention something that we also have done to further enhance our end technology, because there are challenging wastewater applications out there, and we want to have a broad offer for those as well. So we have developed new material of the impeller. Our standard version for what I can call the normal wastewater is the cast iron impeller. But now we also have hard iron impeller. Hard iron material is really suitable for application with a lot of abrasive, like sand, for example. And then we also have a shopper version. The shopper version is typically to be used in application where you have long fibers. What the shopper version will do, it will actually cut the fibers into smaller pieces, letting the breeze pass through smoothly. And then, before we move on, because Flygt Experior has 3 new technologies, I just want to summarize the end technology. So it's about clog-free performance thanks to the self-cleaning functionality. You will be able to save up to 25% energy saving thanks to the sustained high efficiency. And also we have a broad product range, different materials to choose between, depending on your specific need. Okay, let's move on to the next one. It's about the motors. The motor is something that we have been working on since we first introduced the first submersible pump in 1957. So this is nothing new for us. We even have our own department within our product development. But we haven't been so good at communicating our capabilities. A little bit of some highlight before I go into the actual launch is something that not so many are aware about. Namely that we are the largest developer and manufacturer of submersible pumps in the world, no matter of what industry you are looking at. We have a broad experience, as I mentioned, but also we have utilized very advanced calculation tool that we have developed by ourselves to ensure that we develop the right motor that is really optimized for wastewater pumping. We test our motors in our own laboratory during the development phase, and today our laboratory has the CSI approval. But now it's time to introduce new premium efficiency motor on the full range up to 70 kilowatts. We have chosen 2 different motor technologies. For the larger ones, we have a conventional induction motor. But for the smaller one, up to 15 kilowatt, we now have a totally new technology for motors. It is called LSPM. And it stands for Line-Started Permanent Magnet Motors. The benefit with this new motor technology is that it can be started with any method since it's line started. But yet it will have all the advantages as a PM motor, a permanent magnet motor. That means that you will have a high efficiency, and also the pump can be run very smoothly even if you reduce the speed of the motor. Additionally, you will also get a lower running current with this motor design. Something that is very, if we say a flight motor, very typical for a flight motor, is that it is very small and compact, but yet very durable. I will come back to that later. So to summarize, premium efficiency motor. We have premium efficiency motor that meets the IE3 regulations on the full range. For the LSP motors, we also supersede the nominal standard by 4%. You will get, for the LSPM motor, maintain efficiency at reduced speed, and you can start with any starting method. That means that you don't need to have a VFD for the smaller sizes. And now for the most important part, a really new technology that we are bringing to the market, and that is the intelligence. Or as Benny said this morning, it's more than an intelligence, it's really about being smart. And this new product is called SmartRun. Why did you choose then to focus on intelligence? What we have seen during the past year is that customers more and more uses VFD to run the pump stations, to control them, which is good in itself. But we have seen that we often challenges occurs. Challenges such as odor, debris being built up, you can have clogging or sedimentation in pipes. And one of the reasons for that is actually to set the parameters right for a VFD is quite difficult. It's very hard to optimize it for wastewater since it's so unpredictable. So we looked at intelligence and developed Flygt SmartRun. It is an intelligent control. And with intelligence comes that it's all pre-programmed, all parameters is set, and it's very easy to use and to install. You can expect to have several functionalities that you can see in a typical drive, but with a very innovative interface. Because what you more or less have to do after this easy installation is to press the start button. And some of the functions that you can see in the SmartRun is listed here. It's an energy minimizer, pump, sump and pipe cleaning, pump drive protection, soft start and stop, and then external field bus communication. So with those functionalities, you will be able to improve reliability and save up to 30% energy if you compare SmartRun with an on-off control. I will now walk through one of these one by one and to explain how it's working. I will start with the energy minimizer. The energy minimizer is really, really unique. It's a patent solution. And what SmartRun actually will do is that it will strive to run the pump at the optimal speed. So we will search for the optimal speed every day to find the best duty point depending on your specific system design. This is something that normally requires a lot of calculation and theories, but now we have embedded the algorithm into SmartRun. And since this is such a unique feature, I take the opportunity to describe it a little bit further by introducing Hanna, my colleague from Sweden. Hanna is an application engineer, and with us we have an animation. Hand over this to you.
Thank you. First, I'll just go through all of these graphs in this animation before we start it so you will understand it. So with a VFD, or frequency drive, what you do is that you can run the pump at different frequencies, right? As Giovanni was talking about earlier. By doing this, we're able to reach different duty points along the system curve. And by running the pump then at different duty points, we can find a more energy efficient point to run the pump at. And in that way save energy. So what SmartRun does is that it has the VFD functionality, so it's going to run the pump at different frequencies. But what's really unique is that SmartRun is going to find the most optimal point to run the pump at automatically. So you don't need to calculate anything, you just start it and it will actually find and run the pump at the most energy optimized speed by itself. And it does this by monitoring the energy that's consumed and also looking at the flow that's being pumped. And we usually talk about specific energy. And this is a specific energy graph. So specific energy is the energy consumed per pumped cubic meter of water. And for a specific system and a specific pump, you will get a specific energy curve. Looking something like this, it will be different depending on what system curve you have. So you have frequency here and specific energy. And as you see, there's always a lowest point on this curve. And this is the point that we want to run the pump at to be the most energy efficient. So SmartRun is always looking at its specific speed, going down in frequency and finding its lowest specific speed point, and will run the pump at that point. So if you look at the graph at the top, we have pumped volume here. We have the frequency. This is actually a 60 Hertz pump, so it's going to start at 60 Hertz, then work its way down. And you can see the savings in energy when doing so. And here it says days this pump is actually running just once a day. So it's going to change the frequency every time the pump runs. So if you have a pump running more often than once a day, it's going to find its optimum speed much faster. So it depends on how you run the pump. Is that it? So as you see, it's going to start at the top frequency, going down along the system curve. Same here. All the way down until it finds its most optimal point to run the pump at. So what's really unique here as well is that it's looking at what's actually happening in this specific station. Always looking at the true conditions, how much energy am I consuming, and how much am I pumping. So, and this is something that we will continue doing forever. So if you have some change of the system, maybe changing the water levels at the outlet, or something else changes to the pipes, you have higher losses or things like that, then it will adjust to the new conditions that you have. So you get automatic energy savings by just starting SmartRun. Right.
But then I have another question for you. When we are presenting Energy Minimizer, we often get the question about high inflow.
Yes. As Veronica said, reliability is one of the main customer values, of course, with pumping. So we want to be energy efficient, and it's going to run at the most optimum speed for most of the time. Well, for almost all time. But just in case that you have a really high inflow coming into the station, of course we want to adjust to that. So SmartRun is always also monitoring how the water level is going down. So if it notices that it's pumping at its optimum speed, but the water level is not going down, then it's gonna go up in frequency until it reaches the speed where the water is actually being pumped down. So we can take a look at this animation as well. So you're going to see the water level is going up, and it's going to try to start, or it's going to start at optimum speed. But realizing, well, the water is not pumped down, I have to go up in frequency. But as you saw, it didn't have to go up to full speed. It just saw that, okay, with 46 Hertz, I have enough speed to actually pump down the water. So that way, we always make sure that we don't flood the station. It's always going to pump the water away. And if you have a really extreme inflow someday, maybe it's a yearly rain or something like that, then it will actually trigger and start the second pump as well. Since we want to have reliability, we don't want to flood our stations. Right.
Thank you. And by that, I think it's time to move on to the second functionality. It's called pump cleaning, or as I rather call it, clog detection. The reason why we have developed this function is because we want to be sure that the pump is running trouble-free. In case a normal sized object is in the impeller, the smart run will detect that and start a cleaning cycle. That means that the impeller will run back and forward until the debris has been released. Then sump cleaning. What Smart Run will do here is that he will run down to a snoring level, and then he will pump away the floating debris and also the sedimentation in the pump. So what you will get is less odor and of course a clean sump bottom, but also you will reduce the labor and maintenance cost. And in cases if you have to do this work manually, this will also be reduced, of course. Pipe cleaning is about taking away sedimentations in the pipe. So Smart Run will start the cleaning cycle for full speed so that the sand, etc. in the pipes will be moved away into the system. Actually, the pipe cleaning is taking place every 12th cycle today, together with the sump cleaning. Then we have the pump and drive protection. Of course, it's essential to get an alarm if the pump is overheated or in case there are leakage into the pump. And Smart Run will then send an alarm. We also have the start and stop. That means that we will run the pump very gently. We will slowly ramp up at start and slowly ramp down at stop. That means that the lifetime of the valves will be prolonged, and at the same time we reduce the wear and tear. And additionally, we will also make sure, this function will also make sure that you don't have any water hammer effects in your piping system. One common question that we get is if Smart Run has a high capability to communicate with other systems. And the answer is yes, because we are utilizing Modbus. But in case you need to have other protocols, we have that as options as well. So all those functions are embedded, pre-programmed and preset. So it's really optimized for wastewater pump stations. Again, to summarize them, as I said, pre-programmed and easy to install. You just have to press the button. You can reduce energy up to 30% if you compare Smart Run with a traditional on-off control. And also, the reliability will be improved thanks to the pump, sump, and pipe cleaning functionalities. Just to illustrate, we kind of like illustration and interactions. I have an energy calculator with me today. And we state a lot how much energy you can save. But based on our experience, we have developed these tools so we are able to set the parameters depending on a specific pump station. So let us do one demonstration of this. I will walk this through together with you now, and in the breaks or when we're having a cocktail later today, we can show how it's working and do some calculation depending on your specific system. So what we will do is to enter different parameters. If you have any suggestions, you're of course free to come up with them. We can increase the size of the pump, for example. Should we say 22 kilowatt? Then we have to enter the operating time. Any ideas? Or shall we keep 2,500 hours? Someone is agreeing? Okay, we keep that then. Or? Okay. You mentioned 50 cents as an energy cost here, US money in dollars. Is that correct as a parameter? The cost of energy? Is that reasonable?
Point one was correct.
This is in dollars, sorry, in euro or dollars?
In dollars per month.
41.
0.1.
Like this.
Sorry, thank you. And then we have the static head. I can show this illustration. We have added this so we can be sure that we get the correct data, because you need correct data to calculate. What it's all about is defining the ratio between static head and the total head. And here you can see a typical pump curve, and here's your duty point. That means that you have the total head here. Meanwhile, you also have to fill in the static head for your specific system. So by dividing those two parameters, you will have the ratio. In this case, it is 30%. We could increase it to 40, just to play around a little bit with the figures. Then you need to define, depending on your application, what kind of pump media do you have. And here you can choose between clean water, fine screen sewage, or raw unscreened sewage. Any ideas? Raw, okay. And then we have the impeller type, open single vein, closed single vein, closed tube vein.
Yeah.
And technology, maybe not in this case, screw or vortex. What is your best option?
Close two.
And then we must define the motor efficiency. We have 3 different standards, the IE1, IE2, and IE3. My suggestion is to go with IE1 since it's most common. You agree, I can see, loud and clear, but I can see you better than me. And now we are pressing the button. That was good timing. Thank you for that. So what you can see here that with Flygt Experior, you will be able to save with this system up to 62% energy. And in money, which is the most important, is about $3,093 per year. That's quite good. Below here, we can see how it's divided. The N technology will save about 43%, 48%, and the smart run, 48%. What you see here actually is savings coming from the hydraulic and this control unit. If you don't want to add a premium efficiency motor to your Experior pump as an option, so you can take it away and then we recalculate. And in this case, it's 50-50. So Flygt Experior, the way I should put it is, my perception is that we have developed Flygt Experior with the premise that a premium efficiency motor always needs to be combined with a state-of-the-art when it comes to intelligent control and our superior hydraulic design. Because here is where you can find the savings. As I said, we are available in the break, so we can do more calculation and look to other systems as well. Okay. I also brought 3 cases with me. We have had Flygt Experior available for some countries in about 1.5 years. And I think it's always stronger if you have example how we have been able to live up to this bold statement. So I will start first with a case from US, from New Orleans, Jefferson Parish. We installed, the installation we did was in June last year. They had 4 pump stations with duplex installation. The problem they had was clogging. The pumps clogged about once in a month, and one of the 4 pump stations even clogged two to three times per day. And now we are talking maintenance money. We installed adaptive N, and after the installation they haven't had any clogging at all. And just to put some figures on that is one call-out cost about $400 US. You have to send 2 men and also 1 electrician and mechanical guy. So not only have they saved money on maintenance, but they have also freed up time for their resources. We also installed smart run, and they saved 54% of the energy cost. The frequency was in the starting, when we started the pump, it was 60, and then only after 2 days it went down to 38. Just to give you some graphs on that, you can see here in blue how the electricity, the usage for 2011 and 2012. And we know it's changing year by year depending on weather condition, etc. But in June 2012 we installed Flygt Experior, and since then you can see that we have reduced the energy. One thing I think is also worth mentioning, because I'm talking about simplicity, is actually that the retrofit installation only took 1 day. So this is really a good way to illustrate what we can achieve with Flygt Experior. And then, of course, I have a case from Sweden, which is close to my heart. What we have done here is that we have 1 pump station in the middle of Sweden with 2 conventional pumps, 2 competitor pumps. What we did was the customer chose to upgrade one of the conventional pumps, and then the second one we changed to an end pump with adaptive N. We also installed a smart run here in this installation, and we saved 50% of the energy. I will show you here on this graph. I will walk it through with you. Here we have the upgraded pumps running direct on line. The blue line here, the curve is the actual curve, meanwhile the green one is the average. Then we have the same, but now we have running the pump station only with an adaptive N pump together with a smart run. And you can see that we have reduced the energy from 4, and before that it was slightly above 8 kilowatts. So this is how we can achieve 50% savings. Last but not least, in Langenhagen in Germany, we have installed smart run and also Flygt N pumps. And as you can see, their challenge was clogging, 2 cloggings per month. And what we have done is reduce energy by 22%, and we have no clogging today. And here you can see the curve as well. So here is direct online, and then with the smart run, we have reduced the energy consumption. Interesting here is to see, as Hannah explained, how fast smart run will adjust the frequency. It's only within 1 day you can reduce the energy. So then I summarize Flygt Experior with the hydraulic intelligence and the motor. We now have an unmatched reliability for wastewater pumping station. You are able to reduce the energy by 50%, and it's easy to use, easy to install and operate. So by that I have, of course, another film, This is the official launch film of Flygt Experior.